Based on the related project for this video, we will talk about the related rate of the area of a rectangle. Now listen, look, and listen and learn.
By this point, you must be familiar with implicit differentiation, better yet familiar on how related rates work. We know that related rates focuses on the rate of change of an object and how it will change over time. We could write this as d over dt. In terms of getting the rate of change of an area of a rectangle, we must first remember the formula of its area, which is area equals length times width. The length of a rectangle is increasing at a rate of 8 cm per second and its width is increasing at a rate of 3 cm per second. When the length is 20 cm and the width is 10 cm, how fast is the area of the rectangle increasing? First, let's imagine what's happening. We already know the shape of the rectangle, and by reading the problem, we know that this rectangle is expanding as its width is increasing. Now, let's list down what we know. We know that our length with respect to time is 8 cm per second, and our width with respect to time is 3 cm per second. Now, let's write our equation. We know that area equals length times width. We could express it as d over dt times a equals to d over dt times length times width, or simply dA over dt equals L times dw dt plus w times dl dt. Let us solve for what we need already in the form we need. Let's substitute the values we have from the problem to our formula. dA over dt would then be equal to 20 cm times 3 cm per second plus 10 cm times 8 cm per second. We would the value 60 cm square per second plus 80 cm square per second. By adding these two, we would get 140 cm square per second. The length of a rectangle is increasing at a rate of 10 meter per height and the width is decreasing by 2 meter per height. When the length is 100 meter and the width is 50 meter, what is the rate of change of its area? Let us list what we know once again. We know that our length with respect to time is 10 meter per hour. The width on the other hand is different. Notice the word decreasing. This will be our keyword to write this down. So we write this expression as 2 meter per hour as it is decreasing. Now, let us go back to our first problem. We know that A equals L times W. So since we're dealing with rectangles, we would use this again as well as its equation with respect to derivatives. So our equation will be d over dt times A equals d over dt times L times W. Or we could write it as dA over dt equals L times d over dt plus W times d over dt. Basically, this will be our main equation for rectangles whose area is unknown. Now we plug in our given and it will look like this. Remember, our 2 is negative since it's decreasing. Our final answer would then be 300 meter per height. So for every hour that passes that area, it increases at a rate of 300 meter per height. Here's a visual representation of its change.
Now that will be the end of our tutorial. Thanks for listening and looking and listening and learning. See you next time!